Okay. So the remaining homework assignment you have for the course is due on Friday, and as I mentioned in our last class meeting, you can submit that up until 11:59 on Friday night. So we'll continue to cover new material in our class meeting at noon on Friday, and so I think there is one or two problems on the homework that kind of ties into that material from Friday afternoon's class. So that's why I wanted to give you until Friday night to solve the assignment. I've been looking through the projects, and so those are looking good. Our final exam. We are scheduled to have our final exam, by virtue of when the class meets. That means that we're supposed to have our final exam at 10:15 a.m. until 12:15 p.m. on Friday, the 1st of May. So this is the exam schedule that's put together by the registrar at the university, and this kind of governs, it's like the master schedule for when final exams should be. And so that means that our exam, since we meet noon on Monday, Wednesday, Friday, will be on the 1st of May. A bit of information about that exam. The test will be comprehensive, meaning that you could expect questions from at any point during the semester. It could be as easy as me asking you to use an interest rate to find a future value based on a present value, like stuff we did in the first couple of days of class. It could be simple problems like that, or it could be more detailed and in-depth questions on the more recent material. More points will be earned on the more recent content since you had the second exam. So proportionally, since you haven't yet been tested on the more recent content, that's why I want more of the points on the final to come from that recent stuff. But it's going to be a broad mix. Now, we have 2 hours for the exam. I plan to write the exam so that I think the average student is going to need considerably less than 2 hours. I want to, kind of build in the same safety factor that I gave you on the last midterm, having to do with, you're going to be getting the test electronically and needing to upload it to Blackboard. So, during a 2-hour window, I'll try and aim for a test that I think the average student should be able to finish in about an hour. And so then that would give you plenty of time on either side of that with downloading it, printing it, if you have a printer. And it'll be the same sort of thing where you can just solve the problems by hand on a blank piece of paper if you don't have a printer. It'll be the same rules applying in terms of you shouldn't work with other students. You should only work individually without any collaboration or input from anybody else, not just other students. It's solely going to be your work, but you can use the textbook, your notes, previous in-class exercise, homework assignments, and so on. So, any of the resources that you've already made or have access to, that's fine, but once the test begins, you can't have contact with anyone else. So before we get into the new material on the learning curve, are there any questions related to the announcements or related to the final exam? If you have any questions that pop up, you can feel free to send me an email or give me a call and we can discuss it then. Okay. Here's a picture of a factory where garments are being sewed, and if you've ever seen video of people in like a commercial clothing making operation, you probably have been amazed at how quickly they can sew through things. They can make apparel just with lightning speed, and I started to appreciate that all the more when I was forced to take a home economics class back in middle school. Maybe some of the rest of you had a similar experience where you had like a short unit in one of your classes where you had to sew something and you had to cook something and so on. Well, during the sewing part of home ec, I remember how difficult it was actually to sew in a straight line and how to be accurate and most of all, avoid injury with the needle. But these people can just zip through apparel very, very quickly. But they weren't always that good at it. And so let's say that the first time someone goes into the factory and sews a shirt, it takes them 12 minutes. Well, what we want to be able to do is predict how well you learn over time and how much more efficient a worker is at producing output based on their experience. So whether it's a person who's working in an apparel factory, or a construction worker on the job, or an employee who's working inside an electronics factory, whatever the case may be, people generally get faster and more efficient the longer they work on a task. And so what we're going to look at is a model. It's an equation that describes how much time it's going to take to do something after you've gained experience. So in that model, the first input is what was the baseline time required. So how much time was required the first time a thing was attempted. So we're going to assign that the variable k. In any kind of application, this same trend is going to apply. So it may be in the most sophisticated factory. Even when robots are involved, it takes time to optimize the routine of the robots, and there probably isn't as pronounced a learning curve with robots as there is with people, because you can arrive at optimization more quickly if the human foibles are kind of taken out of the equation. But still, the same trend applies, that you become more efficient over time. So now, looking at defining some of the terms we're going to use in this model, besides knowing how long it took you the first time, you need to have some data that describes how the performance improved over time. So let's just say, for instance, that this particular worker, the fifth time they installed an oil pan, it took 40 seconds to install, just for that particular oil pan. And then when they doubled their experience, it only took them 37 seconds to install. So what I mean by doubled their experience is when the person was installing the fifth oil pan, then that means now they've, under their belt, they have a total of 5 oil pans successfully installed. So on the 10th, that is essentially a doubling of their experience. And so that ratio is what we define as S. So you can see here we say that S is the ratio of 37 to 40. Now it's not just limited to the 5th time you do something and the 10th time you do something. That ratio in a lot of cases holds true for any doubling of experience. So if we looked at the amount of time it took to go from the 1st to the 2nd, or from the 2nd to the 4th, or from the 4th to the 8th, or the 10th to the 20th, I think you get the trend. The idea is that when you double experience, there's going to be some ratio in the amount of time that it took, where in the numerator of the ratio you put the less time, and in the denominator you put the more time. So here is a figure that kind of shows what that learning curve can look like. And a learning curve is just a model. It's a numerical summary that can try and predict increased efficiency and productivity. And so in this learning curve you can see the intercept with the axis. The first time something was attempted, we know that's the K value. And then we have a measurement of the 2nd time, the 3rd time, the 4th time. So we have this data and we can do a curve, and gradually it's flattening out because the person has kind of learned all of the easy lessons, picked the so-called low-hanging fruit, and when you don't have the easy improvements to make anymore, then you're not likely to have big sudden increases in efficiency. And so once you've organized your tools and you kind of get a feel for the equipment, then things start to flatten out a bit. This is sometimes called an experience curve. Another name for it is a manufacturing progress function. And so here's the equation and the variables that we use. We've already talked about K, which is the first time you do it. And we've discussed what S is. S is the ratio of time required to double your experience. So when you have, for example, a certain amount of time in this curve, if we just look at this curve, it looks like for the first it was 42 minutes, and for the second it was 37. So our S curve would be 37 divided by 42. What we do with that is once you have the S curve defined, then you substitute it into the equation for n. So here you can see the equation for n is the log of s divided by the log of 2. And it's this n value that goes into our experience curve. So we're going to start with k, which is the first time that something was done. And n is the indicator of the learning curve. And then u is whatever you're trying to predict. So are you trying to predict how long it will take to make the 15th unit? Well, then you would have 15 as your value for u. Or if you're trying to predict how much time it will take for the 30th unit, then 30 would be the u. And you'd have the same k for all of them. You'd have the same n regardless of what you're trying to predict, but what would change would be the u value. Okay, so just to give you a feel for how this works, before we begin on the in-class exercise, let me show you this illustration. Let's say, for instance, that it takes you 85 minutes to sew the first pair of pants that you ever attempt. And then the second pair of pants you ever attempt takes 76.5 minutes, and the fourth pair of pants takes 68.85 minutes. So we've got a little bit of data about how well you're improving. Part A of this question is asking how long would it take you to sew your 10th pair of pants? And so what that's saying is, let's use the same value for K, and so K is the first time. So we're going to have K be 85, and then to define n in this function we have to define the learning curve slope. And we can get the learning curve slope a couple of different ways. We can either have the ratio of 76.5 divided by 85, or we can use 68.85 and divide that by 76.5, because either way that's going to be a doubling of experience. So let me show you what the first part of our calculations look like for part A. So what we do is we have K defined as the first pair that we sewed took 85 minutes. And we can define the learning curve slope, S, as the ratio of the second to the first. So doubling the productivity, it looks like we have a 90% amount of time. So that means that it's only taking you 90% as long to do it the second time as it did the first. And then we can check to see if that trend holds true. And so you'll notice that if we double our productivity from the second pair of pants to the fourth pair of pants, so now we have twice as much experience again, it's that same ratio of 0.9. Okay, so 0.9 is our S value, and if you put that into the equation for the n, the exponent that we're going to use in our experience function, then you'll get that the n is negative 0.152. So it's asking us to predict how long is it going to take to sew the 10th pair of pants. And so it would take 85 minutes times 10 to the minus 0.152. So you'll see that inside these parentheses the factor is 0.704, so that means that in the 10th pair of pants it'll take us 65.9 minutes just for that pair of pants. Now if we go back, that's the answer to part A. Any questions about that part A before we move on to part B, which is how much it would take to sew all of the pants? Okay, Well, let's see about applying this function in Excel, because we need to automate these calculations for many different pairs of pants. And so let me just paste a couple of equations over into Excel here. So here is our function for Z, and pair number we'll have, and then time. And so there's pair number 1, 2, 3, and what this part B of the illustration is saying is how long would it take to sew all 10 of the first pair of pants. So we're going to find out through all of them how much it takes. Alright, and the K, which was the first pair of pants that was sewed, was 85 minutes. Okay, and then let's remember, what did we already calculate for the factor of n? Now, according to our previous calculations here, n was negative 0.152. Alright, so that means we can calculate the second pair of pants. So 2 is going to be u in this function. Okay, so the amount of time it takes for the second pair of pants is k. The first pair of pants is k, multiplied by u, here's u, to the power of n. And I'll anchor that reference to n so that it's always in the same spot when I drag down through. So 76.5, and that matches up with the data that we were originally given. In the example it said that's how long it took, is 76.5 minutes. So far so good. And then if we drag this down through all of them, we can figure out, for example, the fourth pair of pants and the eighth pair of pants. And so here's that 10th pair that we'd calculated in part A. So the cumulative total would be the sum of everything above. So it would be the sum of all of this time. So your first through your 10th pair of pants, so if you had an order to sew 10 pair of pants, it would take you 679 minutes. Okay, so that's how we can apply the experience function. And I'd like you to get some experience with it on this example. So this is the in-class exercise I emailed you earlier today. You should have it in your email. What we're going to do is take the situation of a Rubik's Cube. Now, I've complicated things a little bit. If you look at the data that's provided, you forgot to time how long it took the very first time you did the Rubik's Cube. And that's a complication because that's the amount of time that we need for K. So you're going to need to back calculate what try number 1, how many minutes that took. And I think that you'll be able to predict that pattern because of the rest of the data that you do have. Remember that there is a fixed ratio every time you double the experience. And so if you go from 2 to 4, you're doubling your experience, and so you could calculate a ratio with that. And you could check the ratio going from 4 to 8. And so if you can go forward in time with that ratio, you can also go backward in time with that same ratio. And so you'll be able to extrapolate backwards and predict how much time did it take the first time. And so then that's what you'll use with K. And what this question is asking is how long will it take the 100th time you try? Okay, so I'm going to pause for a moment and let your creative problem-solving abilities begin to take hold. I'll pause, give you a chance to start your calculations, and then we'll rejoin to see if the solution matches up. Okay, so the way that you can find out how much time it took when you forgot to measure it is to look at the ratio of the fourth to the second, so 21.84 divided by 24, and then multiply that ratio by 24. Let me show you what I mean. Okay, so the ratio, the S value for the ratio is 0.91, and that's the same whether you're going from the second to the fourth or from the fourth to the eighth. That ratio has been held constant, and so once you have that N value, then you can calculate the when you've got the S, you can calculate N. So the first time is obviously it took more than the second. So, I mean, just kind of setting expectations and picking a value that's reasonable, it should be greater than 24 minutes. And so the application of this is that the first time would have taken 24 minutes divided by the factor 0.91, so 26.38 minutes is our guess of how much it took the first time around. So if you want to know how long it's going to take the 100th time you solve the Rubik's Cube, then it's going to be a U of 100, and there we go. So it should be 14.09 minutes. Did anybody else get that same value? It's always good to have someone independently confirm and double check the calculations. Anyone else get 14.09 minutes for the 100th
Yeah,
time?
I did.
Good. Thank you very much. Okay. Well, for once, that's a small idea that we're not going to have to rush through too much. We're going to finish a little bit early. We do still have one more class meeting on Friday, but just to wrap up with one last look at the announcements before we part ways for today, homework 13 will be due on Friday, and that homework assignment, let's just pull it open real quick because I want to show you that it does include a question having to do with the learning curve. So here's homework 13, cost estimation. So the learning curve stuff that we've done today, let's see, where is that? Boy, that would be a pity if you didn't have an opportunity to try out the learning curve, and that may be the case. Oh, no, here it is, learning curve. So you have the amount of time it took to do the first robot, the amount of time to do the second robot. So this first problem here is a learning curve type problem, and it's asking you to find the amount of time it'll take to install all 25 robots. And so it's a cumulative type problem, and since it's a cumulative type problem, then most probably using Excel like we did for this illustration will be a good way to get started for that one. Alright, so that's it for today. Thanks for joining. If you have any questions, feel free to send me an email, and I hope you have a great day. I'll see you on Friday.